Okay, let's do problem 4. So problem 4, like I said in the homework, it's not like I have a perverse obsession with simplifying things for no reason. It's that in calculus you'll often get an answer that has like e's and natural logs, and it's kind of messy, and unless you can simplify it, you just won't be able to do further calculus with it. But if you can simplify it, then you will be able to. So, I mean, all of this is for a reason. These are some of the basic transformational rules that you're going to need to apply in order to simplify these things. So let's just look at some. So here's part A. It says what? E to the natural log quantity x squared plus natural log x. All right. So part of being able to simplify this stuff is being able to see algebraic expressions and like see the pattern in it. So when I look at this, I literally see e to the blob plus other blob. And like, I kind of don't pay attention to what's in there. I just see like, oh, this has the same form as this. It's like something to the something plus something. And so I know that I can apply that transformational rule. I can sort of break it apart. And I can rewrite it as e to the natural log x squared times e to the natural log x. You might back up one and say, well, just because you can use a rule, why are we doing that? And the answer is, whenever you have an e and a natural log like this, you're going to want to try and massage it until eventually they cancel each other. So here, these already cancel, so that just gives us x. Let's see what we can do here. So here I've got natural log of x squared. So whenever you have an exponent inside a log, natural or unnatural, you can bring it to the outside, so log a to the b becomes log a. That's weird. Okay, and then, all right, so let's bring that down there. So e to the 2 natural log x. And you might be really tempted to just go ahead and cancel the e and the natural log, because look, they're right there. Oh god, you want to do it. But don't be tempted, because these transformational rules only really apply if the form fits exactly. So again, I see, all right, I've got e to the blob times blob. Here, in this case, the blobs are very simple. One is 2 and one is natural log x. So here I can rewrite this in either way. I can either have it be a to the b, and then that whole thing is raised to the c power, or because you could write this b times c in the other ordering, you could also do a to the c, and then that whole thing to the b. All right, well, so what that means is I could make this e squared to the power of natural log. That doesn't seem that productive. Or I could make it e to the natural log, and then that whole thing to the power of 2. So let's do that. This is just going to keep coming down here. So e to the natural log x, and then that whole thing squared. And then that's still times x. So that does make sense to do, because now these actually do cancel because they have the right form. So that gives us x squared times x. So all of that eventually ends up being x cubed. And this is what I was saying. Like, if you tried to do calculus on, some particular technique on this original thing, it's going to be a freaking nightmare. But here, like, not so bad. So it really, and like, this is not artificial. You really do end up with some, like, kind of ugly stuff if you don't simplify along the way. All right, so that's part A. Let's look at part B. What was part B? All right, so here I've got e to the quantity natural log x, and that's all squared, and then plus natural log x. Okay, cool. So I'm going to start out the exact same way. I'm going to break this into two parts. So this will be e natural log x squared times e to the natural log x. So like each part went to its own thing. This cancels, and so now that's x. Okay, so what am I going to do here? I can't bring this 2 down to the front because it doesn't fit this form. The exponent here is on the outside. It's not the inside. It's like I take the natural log and then I square it. It's not that I square x and then I take the natural log. So none of these really obviously apply right now, or at least not obviously apply. So if you feel stuck, just try and massage it a little bit, like rewrite it in a way that's equivalent. So I know squaring something is like multiplying it by itself, right? So, wait for it. So I'm just going to rewrite this as e to the natural log x times natural log x. And that's all times x. Okay, well now that I see it this way, look, it's e to the something times something. So I can reapply this same rule, right? E to the a, something to the something times something. So I can rewrite it in either of those ways. And here, because the two things in the exponent are the same, it doesn't really matter. So I can rewrite this part as e to the natural log x to the power of natural log x. So now these guys cancel, giving me x. So I've got x to the natural log x times x. And if you wanted to, x is really like x to the first power. And when I'm multiplying, I can make that be a single exponent, where I've got natural log x plus 1. So I feel like that's a sort of nice simplified form for that problem. Okay, good luck.